In this lesson, you're going to use trig ratios to find the sides of a right triangle. The Pythagorean theorem, you start with two sides, any two sides of a right triangle, and you can find the third side. Now, the power of using trig ratios rather than the Pythagorean theorem is that you only need to know one side and one angle. So if you're given one side, doesn't matter which side of the triangle it is, and you know one of the two acute angles, you can use the trig ratios to find all the other sides as well as the other angle. You can also use it if you just know two of the sides. So let's say if I just knew the two legs, I can then find the angles, and that's something you can't do with the Pythagorean theorem, is find the angles. So we're going to look at some examples of how you use these trig ratios. So in example one here, I have a right triangle. I know one side of the triangle, I know an angle, and I'm looking for the other side. So the first step is to identify your reference angle. In that case, it's definitely in the 33 degrees right here. And I'm going to go ahead and label, I like to go ahead and label hypotenuse, and then this W over here, that would be the opposite side. So I now know I have opposite and I have hypotenuse, so that means I'm going to use the sine function. So we're going to write sine of 33 degrees equals opposite, that would be W, over hypotenuse, which is 4.5. And now I can simply solve for W by multiplying both sides by 4.5. Now we write that in front, 4.5 times sine of 33 degrees equals W. All right, the left side here, you can put in your calculator 4.5 times sine, find that sine function on your calculator of 33 degrees. Now make sure your calculator is set for degrees. It should say somewhere on the display DEG for degrees. We do not want it in radians. You're going to learn more about radians tomorrow. So just put that in your calculator and you're going to get a decimal approximation. In this case, 2.45 is the length of W. All right, in example 2, we want to find the lengths of X and Y. So here's our reference angle. I have a reference angle of 50 degrees. And this would be my adjacent side, this would be my opposite side, and there's my hypotenuse. So let's go for, which one do you want to do first? Let's do X. So X is opposite. Now I have opposite, and we know adjacent. We don't know hypotenuse, so I'm not going to use a sign here because I would have two unknowns. So I'm going to use tangent because I have opposite and I have the adjacent here. So let's use a tangent function. So I would say tangent of 50 degrees equals opposite, which is X, over 5. All right, multiply both sides by 5. I'm going to put parentheses around that, equals X. Stick that in your calculator to solve for X. And X is equal to 5.96, we'll round it. Now we need to solve for Y. And we don't want to necessarily use X unless we have to because we have an approximation. So instead, I'm going to use this adjacent side. So I have adjacent, and I'm looking for the hypotenuse, so I want to work with the 5 and the Y. So that is going to be cosine. So cosine of 50 degrees equals the adjacent side, which is 5, over the hypotenuse, which is Y. All right, let's go ahead and multiply both sides by Y. That will give me Y times cosine of 50 equals 5. Now I need to divide both sides by cosine of 50, which will give me 5 over cosine of 50. And then we can get a decimal approximation in our calculator, which is Y equals 7.78. All right, this one is your turn. Solve for the unknown length. So you are solving for X. In this case, I want you to go out to 4 decimal places. And there's your solution. In this final example, I want to show you what a typical ACT question might look like. Now, the only difference here is the ACT question is going to be written in paragraph form, and there probably won't be a diagram, which is something you'd have to draw. But in this case, they would be saying you're standing at the bottom of a hill, you're 30 feet from the base of the hill. So there's our 30 feet. The angle of elevation is 56 degrees. What's the distance from the person to the top of the hill? And so in that case, we're trying to find the hypotenuse. And because you paid attention in Algebra 2 class, you're like, hey, I've got this question. This is my adjacent side. This is my hypotenuse. I am going to use cosine, and the cosine of 56 is equal to 30 over y. And I'm going to just jump straight to 30 divided by cosine of 56. I'm skipping a few steps there. And on the ACT, you would select the answer that said 53.65 feet.